Hi, everyone. How are we all doing? Well, oh, wow, right. Thank you. That's it better be good from here, right? So, no, thank you so much. I'm delighted to be here. It's great to see so many people in person. Great to see people talking about my favorite topic in the world, which is MLOps. Second favorite topic is my son. So it's really great to see you all here today. So I'm going to talk about MLOps at NatWest Group, and I've kind of got the subtitle of the journey so far. And it really has been a journey. So I'll talk through how we started from a point of really assessing where we were and really seeing how we had so far to go to where we wanted to be. And now I feel like we're sort of arriving there, and then some of the next steps we're going to have on that journey. So I know we have about 20 minutes, so I'll try and get through as much of this as I can. So NatWest Group, who are we? Most of you in the room, if you're based in London or the UK, will have probably heard of NatWest Group. So we're one of the biggest financial services organisations in the UK. We're the UK's leading business bank. In fact, 1 in 4 commercial entities in the UK bank with us. And we have around 19 million customers spread across our retail and our business entities. And so we have this huge customer base. So we're a really core part of the British economy and of British society, really. And we take that very seriously, as you can see from how we try and champion people, their families, and businesses to thrive in our purpose. We are a big organisation. We have around 60,000 people worldwide, spread mainly across the UK, India, and Poland. And interestingly, for this audience, within that, we actually have a very large contingent of data scientists and engineers. So around 500 data scientists and engineers operating across our hub teams, so the data innovation team where I work, and our lines of business teams working across retail, financial crime, fraud, commercial banking, etc. So we have a really big contingent of people who are very smart, very talented, and want to drive value from the data we have. And using that data has led to, in the past, around 3,000 models being deployed in the bank and ran. Now, that's not 3,000 ML models, before everyone gets extremely jealous. The vast majority are actually credit risk, IRB models, more traditional modeling approaches that financial organizations have been doing for decades. But the percentage of these models that are AI or machine learning driven is dramatically increasing. And that has then led us to take stock and evaluate how are we going to manage and operate all of these models as they grow and as they become ever more important for enabling our strategy. And that's why we started asking, so what does it mean to develop an ML solution? So you've probably seen this diagram before. It's from a paper in 2015. I'm a bit shocked when I see that because I've been using this so much, but that's quite a long time ago now. From a paper, Hidden Technical Debt in Machine Learning Systems by a lot of the engineers from Google. And it's really showing what I think a lot of you in this room will appreciate quite acutely in your day-to-day. And that is that an ML product, an ML solution, only a small part of that is actually the code that does the machine learning. It's only a small part that does feature transformations, taking data, munging it, wrangling it, transforming it, feeding it into a model to train and then inference. There's a whole host of other items and elements and pieces that need to integrate together in order to deliver products that will drive value based on that data. And that's what MLOps to me is really about. It's not about just optimizing that little black box in the middle. It's about providing a holistic view of all of this taken together in practices and capabilities to enable the delivery of real ML solutions within the business. But that's kind of all good in theory. What we then had to do as an organization was ask ourselves, where actually were we in this journey in producing real MLOps solutions? So we did a bit of an exercise a couple of years ago where we started isolating where our main pockets of challenge were across the organization. And we basically bracketed them into 4 areas. So on the people side, we have a lot of very talented people. I've already mentioned this in the bank. But we were struggling to really make sure that they all had the correct training. They were all speaking the same technical vocabulary, all working in the same ecosystems, and that they had the right operating model built around them to make sure they were in the right place at the right time to drive value. On the process side, some of the parts of NatWest Group are hundreds of years old, RBS, etc. So we have a lot of, I would go on a limb and say, antiquated processes. We have a lot of very intensive governance processes in place. And a lot of these are performing important functions. So as a financial services entity, we obviously have very strict regulatory and compliance concepts that we need to adhere to. But the question here is, are we being optimal within the parameters that we have to follow? We then had challenges around data. So 19 million customers, 1 in 4 UK businesses. We have a lot of data. So we're not short of data, that's not the problem. The problem was that the data scientists and those building these real ML solutions were not able to access the data to do what they had to do in a seamless manner. So anytime we built up a solution, we had to do some really complex integrations, some really complex analysis, just to get the right data provisioned for the right people. And then finally, a bit more generally in technology, and this is maybe one we've all experienced over the past few years as technology moves so fast. In this, again, quite old financial services organization with a lot of history, we've tried every technology as it's came up, and a lot of them have hung around. So we have a very complex, fragmented estate, where again, if you wanted to build a solution end to end, you had a lot of complex and costly integration points you had to manage. So how do you take this old SQL database, marry it with this new data lake? How do you transfer data over here? How do you orchestrate across all that? All of that was a bit challenging and difficult. So we laid out a bit of a vision a few years ago, our MLOps vision, and we said what we're going to do is we're going to modernize the stack and use best of breed components, and that'll help us not just do things kind of more optimally from a pure technical point of view, but also help us attract the best talent, because everyone wants to work where the technology is the best and where you can speak that consistent language that I mentioned before. We want to simplify the data access for data scientists. So if you're going to go build a model, it's sort of articulated how you get that data, and you already have the access you need. We wanted to optimize our governance, which I would actually say is, you might not think this on the face of it. I'd say this is probably the most ambitious one for an organization like ours. We thought, how can we take that long, complex governance process with lots of manual handovers and automate it where possible? And then how can we standardize? So how can we maintain the quality of the products we're building by providing standardized templates, patterns, and ways of doing things that can be rolled out across the entire enterprise? And all of that ultimately is going to drive faster time to value. So we already had machine learning models in production when we started this journey. We were already delivering value. We were seeing good ROI, but we weren't seeing enough throughput. So we basically said, right, the key thing here is to up the velocity of our delivery. It's not just to say, can we do machine learning in practice? We've solved that problem, essentially. We know we can. But can we do it time and again, reliably, robustly, scalably? So what we did was, about 18 months ago now, we engaged with AWS, with their professional services arm, and we set up a joint venture where we were going to work together to build our MLOps platform and capabilities on AWS. So we did more of a kind of self-analysis piece where we tried to place ourselves on this MLOps maturity curve. And what you can see here is that as your maturity grows, you should move from the initial experimentation phase in terms of platforms. You know, you're having your first stab at an AWS environment or a Google Cloud environment, et cetera, but you're not really putting it all together in the right way. We then want to move up to things being repeatable, and then eventually completely reliable and monitored, and then eventually fully enterprise scale. And what was key here as we began this journey was we needed to articulate how we would know we were actually progressing up this curve. It's one thing to say NatWest was here and put it on a slide. The other thing is to actually say, how do you quantify that? So we defined a series of business-based KPIs, some of which are listed here. So how long was it taking us to deliver something? Previously, it was around 12 months from idea to production. How long was it taking to access data? If you knew the data you wanted, it's about 5 days to send in the form, a centralized team to provision it. How long was it taking for you to, once you had an ML model, actually put it into production? 3 to 6 months, and that was optimistic, I think. How long was it taking to create your environments? More than 30 days. And how many sort of different model execution patterns were out there? And many. It was a zoo, a wild west, essentially. We had a series of other metrics, but the key thing was making the language behind all these really simple and clear. So when we spoke to business stakeholders and we said, we want to do MLOps, they weren't thinking, what does that actually mean? We were actually saying, we want to deliver solutions based on your data more quickly. We want to drive value more repeatably. We want to make sure that your team are working against a standard set of ways of doing things. And that all made complete sense to the teams we were speaking to. So we took that initial stage. We realized we'd had our first stab at the cloud. We'd sort of experimented, but we had a long way to go. So the first thing we started planning out, really, and all of the sort of images I'm going to show in the next few slides are taken from our blog post we did with AWS. So if you go on the AWS machine learning blog, there's a 4-part series on how NatWest migrated to the clouds. So I would recommend you look them up in case you can't read the very small writing. But the route to live concept was absolutely critical here. So what we were saying was, can data scientists who are used to building, and a few talks have mentioned this already, building the proof of concept, the minimum viable products, the initial stabs at something, how do we get them to understand and then move through a development process to rigorous testing as if you're in production, and then eventually to a production world? And how do we enable that automatically through things like CI/CD? So we had to lay that out, that route to live, and we settled on this one. So we would have a development account where you would do your initial development. We then have a test account which would mirror production as closely as possible, production data, the ability to schedule and orchestrate, etc. And then eventually you'd promote into production. But even this concept for a lot of our data science community was a sea change because they weren't from software engineering backgrounds. So they hadn't really thought about how do you set up these environments and segregate them. And then we're on AWS, so we're going to adopt SageMaker. But what we did here that was quite important was we started building out an architecture around SageMaker that really benefited from the modularity available on any cloud, but especially on AWS's components. So you can see sort of some elements in here where there's repetition. That is the idea that within your set of accounts for your team, you can spin out multiple projects, and you can do it in a way that's consistent each time. We also have things that we'll come on to a bit later, our SageMaker pipeline templates. It means every time you roll this out, you're doing things in the same consistent way, and the data scientists know where they need to provide their value add. So change these steps, don't write the whole boilerplate yourself. And then we started thinking, what's the process around this? Because that, I would argue, is probably more important than the technology you choose. How are you going to actually operate this in practice? So we now have a system in place, a process where a project owner will make a request. We'll have some base infrastructure created. They'll then move to a self-service provisioning of more infrastructure using things like AWS Service Catalog. The data science leads will then be able to go and provision new projects within SageMaker. The development team will then update the templates I mentioned. So they're going in and saying, I have a standard classification model. They have the pipeline end to end, but they know they can provide the new feature transformations and the model logic in the right places. And then eventually they execute that route to live I mentioned. And just again, having this on a sheet of paper that you could show to data scientists really helps them sort of understand how they can go from idea on a page through to production much more quickly. But then we go into the challenges around how do you do this scalably from a platform point of view. So the AWS and NatWest joint team really thought long and hard about the right architecture here. And one of the key bits that enables the success and the scalability of the platform is this idea of the shared service account sitting at the center. So within this account, you have all the main components that are reusable across all of the use case accounts. So the standard Docker templates, any other standard infrastructure pieces, code artifact, Elastic Container Registry, etc. And the idea is that then any new use case that is spun up takes that shared account resources and mirrors it. And then what that means is if we have to update across the entire platform, we update in one place and we can propagate the changes downstream. Also means if we have a bug in what we're doing in the shared service account, there's more issues, but that just means kind of tighter platform engineering controls. But this is really key to enabling that scaling piece. So we're not doing everything again and again ad hoc. We're doing it one way again and again. We then had to think a lot about how we organize ourselves. So I mentioned that people challenge. So how do you make it clearer to people what they should be doing, how they should be doing it, how they relate to the others in the team? And one quite powerful way of doing this is the idea of roles. So everybody who uses the cloud obviously knows about IAM policies and the roles you inherit and the roles you embody. But we've actually seen this as a good tool for helping people structure their workflows as well. So here we've got two main buckets of the user roles we have. So one side are the platform roles, the fix engineer and the general support engineer. And then on the other side, we have more the application development team, so the data scientists and the ML engineers. And what's been important there is we have these two roles in particular I want to draw your attention to, which are the model approver and the technical lead. So the developer is really your data scientist or ML engineer. But here we have a model approver role, and the idea here is that they're the touch point with our classic governance processes. So we have internal model risk and audit processes. The model approver's role is to make sure that is all ticked off. They're taking ownership of this thing that's going into production, and they will then push the actual button that does the final promotion automatically into the production environment. So it's really good because that bridges our old processes that everyone's quite well acquainted with and knows about, but brings it into the cloud. And then our technical lead, the real powerful thing here is that before the data science lead was just the one who was in charge of organizing the team and building the models. We've now given them a lot more autonomy because now they actually self-provision the infrastructure they need, but it also means that they have more responsibility. So it's a kind of, it's a give and take sort of relationship, but we think that's quite empowering for them. So the technical leads now actually have far more of a role to play. It's them who choose the type of templates they want to spin up as they do their work. And all of this is using things like the principle of least privilege to make sure our security profile is maintained, which is super important for us as a bank. I want to spend a few minutes then talking about what the experience is actually like. So this is how you provision, get things spun up, we then have to put it in the hands of the data scientists and ML engineers for them to do their work. So what does that look like? Anyone who's used Amazon SageMaker might know about SageMaker Studio. So it's basically an in the cloud sort of setup where you have some of the equivalent functionality of an IDE, you have notebooks. But the key thing was the notebook and IDE pieces being there together helped the data scientists transition slightly from where they were comfortable working in notebooks before and IDEs was maybe a newer concept to them. Here they have them side by side and they realize we're not saying you're all software engineers from tomorrow. We're actually saying it's a softer transition that you're going through. But we also enable integrations with on your local IDEs as well. So if you have PyCharm set up, etc., you can work in them using your good Git practices, build your templates and your solutions and migrate these up to the cloud as well. So feedback's been positive so far, but we're seeing increased adoption, which we'll talk about later. So we're still waiting to hear if all the data scientists absolutely love Studio or we need to do something different. Once you're in Studio and you're interacting and you're playing in the notebook, you're building your models, then what do you do? So we've settled on really this concept of SageMaker pipelines. I think personally pipelining, I was saying this to someone earlier, I think pipelining is probably one of the biggest conceptual shifts for data scientists thinking of how do you get an MVP but into production. I think a pipeline is really it's the building block of the solution. Your ML code starts branching out into a solution when you start building pipelines and scheduling them and orchestrating them and testing them. So SageMaker Pipelines is one tool that provides a good way of doing that, a good backbone. So you can see it provides lots of different step types. What you can then do is in very simple Python, chain them together. And you can see how it's very simple calls in the SageMaker SDK. You can do your pre-processing, your training. You can call out to other services as well. But the key thing here was we're providing that framework for people. So all of the templates I mentioned before are basically examples of these sorts of pipelines. So here we've got a training ML pipeline. They would basically get pre-provisioned in their SageMaker project, a repository connected to version control that has all of these components there. And what we do is provide training to say, okay, for your model, you're changing these training steps, or you're changing this inference step. And that just reduces the amount of boilerplate they have to worry about, and again, eases that transition from saying you're building MVPs and doing research through to you're building a product. But AWS is not always the full story. AWS has a massive amount of tooling, but we've recognized that we want to be able to adapt what we have and the sort of tooling we provide. So here I've put a kind of purple box around our standard MLOps platform as it sits just now that we've been building with AWS. Sorry. But what we're looking to do is say which parts of this can we actually augment with better solutions. So we started looking at how we can add extra workbench items for specific MLOps tasks that we think there might be solutions out there that do things slightly better than the off-the-shelf AWS solutions, for example. So here we've got capabilities we've brought in based on model management, model monitoring, explainability, and bias. I'll talk about one today, but the idea is basically the same. These will be systems or solutions that we bring in, host on-premise, host them on AWS, but they're basically provided by a third-party SaaS solution. And because the architecture is so modular, we can just swap in the previous component that was doing it. And eventually, if we don't like it, we can switch into another one. So on the model management side, we've recently adopted Comet ML. And the idea there is that rather than using the SageMaker experiments and trials capability, we're now trying to use this Comet ML solution within the wider architecture and seeing if that benefits us. And the beauty is, as I said, we can go back, we can swap in new items as we see it driving improvements. So Comet, like any good model experimentation, model registry solution, has It has really two key behaviors. So we mentioned MLflow earlier in one of the talks. MLflow was really good at sort of introducing a lot of this language to the community. But the two basic ideas are experiment tracking. So as you develop, run lots of hyperparameters, try lots of different model versions, how you track all of that. So that's kind of like your scientific logbook as you progress. And then you have model registry, which I like to think more as it's the kind of library where you've said, right, these are the pre-approved kite-marked models that are going up and are tagged so that if you want to go into production and you have a pipeline, you can go into this library and pull out the one that's tagged production, the one that's tagged ready to use. And then that enables lots of other things, your A/B testing, your champion challenger logic, etc. And then what we've done is made sure, or we're making sure now, that this marries into that route to live I mentioned before. So the different capabilities of these MLOps tools that we can buy off the shelf that do their job very well, we need to make sure they're hooking into this route to live appropriately. So here we can see an experiment tracking, that's very much a development activity. Model registry is more about how you test and then eventually how you productionize the model. So there's been a lot of capabilities I've discussed there on the platform. So we've got production-ready ML workflows coming out of this self-service way of working. We've provided auditability because we have these MLOps tools that we've brought in. We are actually now finding as well that through the standard way of working, we've increased collaboration among our data scientists. There's a real community buzz now around this one platform, this one sort of set ecosystem. So we're all speaking that same language. We're energizing the people in those sort of different challenge buckets I mentioned before. And 1 or 2 points I'll mention now is that we've been able to not just speed up, but also enable a bit more sustainability. We were talking a lot earlier about sustainability. I know the next talk's going to talk a lot about this as well, but we've done a small piece of recognizing that our new way of working can actually enable more sustainable compute practices. So I'm going to call out some specific examples where we've actually driven this faster time to value piece. Mentioned that in the title, so that's the overarching thing for us. So here on the left-hand side, I've shown our operational process before and then after. There's lots of boxes, lots of steps. Don't worry about reading it. But the point is, to get anything set up was very painful, and a centralized team would get all these requests from all these different data science teams. They would have to triage, they'd have to set things up, they'd have to do things quite manually. And all in, we reckoned that this part of the process would take around 40 days to sort of get anywhere. That's before you start trying to drive any value. We've now got that down to 5 to 7 days. And one of the biggest improvements we've seen in it is in the actual provisioning of the environment. So previously, this would take, what have I put there? A couple of days, 5 days. So a working week for the request to come in, the Terraform scripts to be run, some other scripts to be run, some things lifted and shifted, configurations changed, DynamoDB is updated. We've now been able to optimize the process as well as use technology to now optimize this. So we use the SageMaker projects piece I mentioned, AWS Service Catalog, which is a great product for bringing together a lot of your infrastructure as code, your security templates, etc. And then we have our own Terraform workloads as well. All of these taken together mean that an actual environment, the actual technical building of it now takes less than 2 hours rather than that 5 days. Now, there are some fluctuations around that. What we're trying to do is make sure that that's the experience every time. Not all of our customers or internal customers are really feeling that yet. But the point is we've now seen how we could do it. So the idea is to just grow that capability and roll it out. So we're now starting to gather the statistics on the models going into production and where we think we'll be sort of next year, et cetera. And again, this is a moving thing. There are fluctuations around this, but we now think we've got the capabilities to deliver an end-to-end solution in 3 months instead of 12 months. The ability to access your data using the standardized access patterns we have in the templates through to our data lake in less than a day, rather than several days. The route to live can, we think, now be executed roughly less than 2 weeks once you have the working model and you've done all the governance. We can do self-service environment creation, as I showed there, in much less time. And we've now started reducing the number of different ways you can actually execute your models on the cloud, because it's all set up for you. So why would you go and build your own, basically? So we've moved up this curve, and now we think we're now pushing towards really scaling this out completely. I mentioned the sustainability piece, so just have a quick nod to this, because I think this is quite an interesting thing that came out of this exercise as well, was by using the AWS managed services. So I had a lot of interesting conversations with AWS about what's the difference between a managed service and serverless. I can talk about that over coffee, because now I think I understand. But basically, we're only paying for what we use, which is the key piece for managed services or serverless anyway. And what that's meant is we've had a dramatic reduction on a case-by-case basis of what it takes to train a model. So we found that we have about 54% less running time on some of the standard models we were running on very large data sets. And that's equated to around 75% less CO2 emissions. And this is really important because we're trying to become net zero by 2050, and in fact reduce the climate impact of our financing activity by half by 2030. So this is quite an interesting dimension where MLOps can actually help the sustainability agenda as well. Final piece I'll mention is that was all about technology really, and some bits of process. But what we've done is also spin up an adoption and engagement workstream, which has been absolutely critical to the success of this platform. And that sole purpose is to get people onboarded onto the platform and understanding the tools, understanding what MLOps is, understanding the new processes. So based on that team, it's now sitting at around 10, it's growing up to 20 people, I think. We've trained hundreds of data scientists and engineers. I think we've rolled out nearly 1,000 AWS courses across the organization. A lot of people are now taking certifications, etc. We've established new MLOps accounts for all the teams that are basically asking for it. We have a backlog of use cases we will help on board. And we're continually tracking and reporting their progress, making sure that problems are being solved in a way that's quite consistent. So we've really viewed this as sort of a service layer on top of the technology. So although there's a lot of self-service there, you still have people to help you. I'll just quickly finish. I'm probably being pushed out time-wise, but basically Zach Anderson, our Chief Data and Analytics Officer, has been a major proponent of all of this. He has recognized quite publicly that this has made a massive impact to the organization and to our customers. And so with that, I will finish, and thank you so much for your time.